Welcome to the lesson on battery electric vehicle standards for high voltage systems. As safety is crucial when dealing with high voltage systems, in this lesson you will learn about some of the main key terms and standards adopted in the automotive industry, including information about voltages and its importance for BEV technicians. Let us look at our lesson objectives. By the end of this lesson, you will be able to name the key industry standards and regulations for BEV high voltage systems. Next, you will be able to describe a floating ground. Following that, you will be able to explain the one-hand rule. Subsequently, you will be able to describe an interlock circuit. Later, you will be able to describe an isolation fault detection system. Lastly, you will be able to describe the levels of voltages. Working on high-voltage systems and BEVs requires strict adherence to safety standards to ensure the well-being of personnel and the reliability of the vehicles. These standards are continuously evolving to keep pace with technological advancements and address emerging safety concerns. By adhering to and staying updated on the standards and regulations from relevant organizations such as the Code of Federal Regulations, technicians can ensure their safety and the safety of others and prevent electrical hazards. In this lesson, we will cover the key terminologies and concepts essential to understanding the standards required for BEV high-voltage systems. Next, we will look at the levels of voltage found in BEV high-voltage systems. In this section, we will cover the key terminologies related to the industry standards and the terms commonly associated with high-voltage systems in BEVs. Let us begin with the key terminologies. The Code of Federal Regulations, abbreviated as CFR, is the official compilation and codification of the general and permanent rules and regulations published in the Federal Register by the executive departments and agencies of the federal government of the U.S. Within the Code of Federal Regulations, there may be specific sections or regulations that pertain to BEV high-voltage systems, particularly concerning safety, manufacturing standards, and operational requirements. The Federal Motor Vehicle Safety Standards, abbreviated as FMVSS, establish minimum performance requirements for various safety features in motor vehicles to protect drivers and passengers. While the Federal Motor Vehicle Safety Standards may not specifically address BEV high-voltage systems, they encompass regulations that indirectly impact the safety and performance of these systems, such as crashworthiness standards and requirements for electrical systems. The Federal Motor Vehicle Safety Standard regarding BEV high-voltage wiring can be found in the Code of Federal Regulations. Title 49, specifically in FMVSS 571.305. This standard outlines the safety requirements for electric power systems in motor vehicles, including high-voltage wiring and BEVs. It covers aspects like electrical system integrity, protection against electric shock, post-crash safety, labeling, and marking. The National Highway Traffic Safety Administration, abbreviated as NHTSA, is responsible for administering vehicle safety laws and regulations in the U.S. The National Highway Traffic Safety Administration publishes non-binding guidelines for BEV design and safety, including recommendations for high-voltage system protection, labeling, and training for technicians. These guidelines help manufacturers ensure that BEVs meet certain safety standards, including those related to high-voltage systems, and provide guidance on best practices for mitigating risks associated with EV technologies. CAT stands for category and is a standard rating established by the International Electrotechnical Commission, abbreviated as IEC, to define safety categories for electrical meters and other test equipment. CAT ratings indicate the level of protection the equipment provides against overvoltages that may occur on power distribution systems. They consist of 4 categories: CAT 1, CAT 2, CAT 3, and CAT 4, with CAT 4 being the highest level of protection and CAT 1 being the lowest. These ratings help users select the appropriate test equipment for specific applications and ensure safe operation in various electrical environments. A floating ground refers to an electrical circuit that is not intentionally connected to the Earth's ground or any other reference point. Floating grounds are often used in applications where isolation from the ground is necessary to prevent ground loops and minimize interference in specific electrical systems. We will discuss floating ground in further detail as we proceed through this lesson. BEVs utilize 2-wire high-voltage systems where the battery circuit avoids direct contact with the vehicle chassis. In a two-wire high-voltage system, the electrical circuit is completed using two conductors, one for the positive voltage, typically referred to as the hot or positive wire, and one for the return path, often referred to as the neutral or negative wire. These wires carry the electrical current between the various components of the high-voltage system, such as the battery pack, electric motor, power electronics, and auxiliary systems. Floating ground describes the condition where the negative terminal of the high-voltage system is not directly connected to the vehicle's chassis. Instead, it floats or remains isolated from ground potential. This ensures that there is no direct electrical path between the high-voltage system and the chassis, reducing the risk of electrical shock or damage to the vehicle's electrical system. It is called a floating ground because the circuit lacks a reference point to Earth-like standard 12-volt systems. This isolation system improves safety by preventing accidental grounding and potential electric shocks through the chassis. High-voltage components like the battery, inverter, and motor have dedicated positive and negative high-voltage wires for power delivery and return paths. These wires are also isolated from the chassis. Technicians familiar with 12-volt systems are accustomed to identifying ground wires connected to the chassis. This grounding path allows for fault detection and protects against shocks. In high-voltage circuits, the absence of a chassis ground means technicians need to be aware of the unique wiring configuration and follow specific safety protocols. Each high-voltage component has its own designated ground wire within the isolated circuit. Some BEVs utilize 12-volt auxiliary systems for powering low-voltage components like lights and infotainment systems. These systems typically follow traditional grounded wiring schemes with connections to the chassis ground. Technicians working on BEVs require specialized training and safety equipment to handle high-voltage components and diagnose potential faults within the floating ground system. The one-hand rule is a safety practice that mandates keeping one hand in your pocket or behind your back when working with circuits or components carrying voltages above a certain threshold, typically specified as 60 volts direct current, DC, or higher. It minimizes the risk of electrical shock by preventing current flow through the body, which can occur if both hands are in contact with conductive elements of different potentials. When you touch something energized with one hand and another conductive object, like a tool or another part of the circuit, with your other hand, you create a direct path for the current to flow through your body, potentially causing severe injury or even death, especially if the current passes through your heart. Keeping one hand tucked away minimizes the chance of completing a circuit through your body. Even if you accidentally touch something energized, the current will likely take a different path, potentially causing localized burns or muscle contractions, but significantly reducing the risk of life-threatening shocks. Remember, the one-hand rule is not a substitute for proper safety training and equipment when working with high voltage. Always wear appropriate personal protective equipment like insulated gloves, safety glasses, electrical hazard shoes, and flame-resistant clothing. Additionally, ensure you have the qualifications and knowledge to safely handle high-voltage systems. An interlock is a protection circuit that disconnects the voltage from the high-voltage circuit if any of its connectors are open. Interlock circuits typically use switches, sensors, or other devices to detect specific conditions, such as the state of the high-voltage components, the presence of voltage, or the operation of certain functions. In BEVs, interlock circuits monitor the high-voltage circuits for breaches and isolate them in case of faults to prevent electric shocks or damage. Different manufacturers utilize various methods for interlock circuits, but the general principle remains the same, that is, detecting abnormal conditions and isolating the high-voltage circuit in case of a fault. An isolation fault detection system, abbreviated as IFDS, is a safety system designed to monitor high-voltage circuits in a BEV and detect any unintended contact between those circuits and the vehicle's chassis or other conductive elements. This isolation is essential because high-voltage circuits can carry up to 800 volts, which can be extremely dangerous if they come in contact with the chassis and potentially cause electric shocks. The isolation fault detection system typically takes multiple actions when a fault is detected. The system stores specific error codes in the vehicle control module, abbreviated as VCM, to aid in diagnosis and repair. It illuminates the malfunction indicator lamp, abbreviated as MIL, which is like a check engine light on the dashboard of an internal combustion engine vehicle, alerting the driver to a potential issue. In some cases, the system may disable the vehicle to prevent further damage or potential risks in case of a severe fault. This diagram displays a high-voltage battery safety system in a BEV, including an isolation fault detection system. The main components are the hydropulse, electro-hydraulic power unit, abbreviated as EHPU, high-voltage battery, disconnect switch, sense line, chassis ground, and potential leak paths. The hydropulse is a hydraulic pump that generates the pressurized fluid for the system. The electro-hydraulic power unit is a combined unit that houses the electric motor and the hydraulic pump. The high-voltage battery powers the vehicle. The safety disconnect switch isolates the high-voltage battery from the rest of the system. The sense line carries a signal from the system to the battery management system, abbreviated as BMS, to monitor the pressure and temperature of the hydraulic fluid. The chassis ground is the electrical ground connection for the vehicle chassis. Potential leakage paths are areas where the hydraulic fluid could potentially leak and come into contact with the high-voltage battery or other electrical components. The hydropulse generates hydraulic pressure for the vehicle's systems, but it is isolated from the high-voltage battery by the disconnect switch. The sense line monitors the hydraulic system and sends information to the battery management system. The potential leakage paths highlight the importance of preventing hydraulic fluid leaks that could compromise the vehicle's electrical safety. This system is crucial for the safe operation of BEVs by protecting drivers and technicians from potential electrical shocks. According to the Federal Motor Vehicle Safety Standards, every BEV in the U.S. must have a system to prevent electrical shocks after a crash or accident. Section S5.3 of the law specifically focuses on the electrical safety of high-voltage sources in BEVs. This section states that after each test specified in Section S6, crash tests and electrolyte spillage tests, each high-voltage source in the vehicle must meet one of the following requirements. A. Electrical isolation requirements. This involves maintaining a certain level of electrical resistance between the high-voltage circuit and the vehicle chassis, preventing current flow and potential shocks. The specific requirements depend on the DC or AC nature of the high-voltage source and the voltage level. B. Voltage level requirements. This applies to vehicles with a maximum continuous high-voltage source below a certain threshold, 48 volts DC or 25 volts AC. Vehicles meeting this requirement are considered low voltage and subject to less stringent electrical safety regulations. C. Physical barrier protection requirements. This involves using physical barriers to isolate the high-voltage components from the passenger compartment and other areas where occupants or rescuers might come into contact. This can be used in conjunction with electrical isolation or voltage level requirements. These are the key aspects of the Federal Motor Vehicle Safety Standards FMVSS 5.3 regulations and their role in promoting electrical safety regarding the isolation fault detection system. In this section, we provide you with information regarding the different levels of voltages associated with BEVs. Let us now look at voltages. Voltage is the driving force that pushes electric charges through a circuit. The high-voltage symbol is a graphical representation used to indicate the presence of high-voltage electrical equipment, circuits, or components. It typically consists of a bold, jagged lightning bolt or a series of jagged lines arranged vertically or horizontally. The symbol is often displayed in yellow or orange on a contrasting background to enhance visibility and alert individuals to potential electrical hazards. The symbol serves as a warning indicating the need for caution and adherence to safety procedures when working with or near high-voltage systems. It is commonly found on electrical equipment, machinery, switchgear, control panels, and other installations where high-voltage components are present. Additionally, the symbol may be accompanied by text or labels specifying the voltage level or other relevant safety information. Whenever you see the lightning bolt symbol, be extra careful and look for wires with bright orange coverings. These wires could be carrying dangerous electricity. Always follow safety procedures and refer to the manufacturer's guidelines. Now, let us talk about different levels of voltages, namely low, intermediate, and high. There is no universal color standard for outer covering for voltages that are 60 volts or less. Let's look at them like water pipes of different sizes. Think of low voltage as a tiny garden hose. It has low pressure, around 30 volts for direct current, like batteries, or 15 volts for alternating current, like wall outlets. It is safe enough to touch accidentally, like a gentle sprinkle. RMS stands for root mean square and expresses the effective or average voltage in an alternating current circuit. So, when we say 15 volts AC RMS, it means the effective voltage of the alternating current is 15 volts. An example of low voltage in a battery electric vehicle is an instrument cluster. This displays information such as the speedometer, odometer, and battery level and operates around 12 volts DC. Next, let us look at the intermediate voltage level. This is like a medium-sized pipe used for watering lawns. It has more pressure than low voltage, between 30 and 60 volts for DC or 15 and 30 volts for AC. Be more careful with this, like watching where you step near a sprinkler. Regarding outer color coverings for intermediate voltage levels, General Motors, the automotive manufacturing company, has blue outer coverings on wires or components to spot it. However, there is no universal color standard for intermediate voltage level outer coverings. A DC to DC converter is an example of an intermediate voltage level component in a BEV. The final voltage level is high voltage. Think of it as a big fire hose. It has a lot of pressure, over 60 volts for DC or 30 volts for AC. It can be very dangerous, like an extremely powerful jet of water. Look for the orange outer coverings and treat it with extreme caution. The battery pack in a BEV is an example of a high voltage level component. Let us now look at a summary of the voltage levels. A low voltage level is comparable to a tiny garden hose with low pressure. In direct current, it is around 30 volts, and in alternating current, about 15 volts, safe enough to touch accidentally, like a gentle sprinkle. It is marked with root mean square, or RMS, for effective voltage in AC circuits. Intermediate voltage is similar to a medium-sized lawn watering pipe, with more pressure than low voltage. It ranges between 30 to 60 volts for DC or 15 to 30 volts for AC. Intermediate voltage level requires more caution. There is no universal color standard for the outer coverings for the intermediate voltage levels. General Motors has a blue outer covering for intermediate voltage levels. High voltage levels are similar to a big fire hose with a lot of pressure. It exceeds 60 volts for DC or 30 volts for AC. It is very dangerous. The coverings are identified with orange markings and require extreme caution. Now that we have discussed the different levels of voltages, remember that there isn't one single rule book for voltage levels and everything. However, companies often set their standards for different situations. Remember, to be safe, always confirm the color and the specific voltage of anything you are working with the manufacturer's guide. Let us now look at the lesson summary on battery electric vehicle standards for high voltage systems. Working on high voltage components in BEVs demands strict adherence to evolving safety standards from organizations to safeguard personnel and ensure vehicle reliability. In this lesson, we covered key terminology and concepts essential for understanding BEV high-voltage systems. We discussed standards such as the Code of Federal Regulations, the Federal Motor Vehicle Safety Standards, and guidelines from the National Highway Traffic Safety Administration to ensure the safety and reliability of high-voltage systems in BEVs. CAT ratings, established by the International Electrotechnical Commission, define safety categories for electrical meters and test equipment, ranging from CAT 1 to CAT 4, aid users in selecting the appropriate equipment for specific applications, ensuring a safe operation. We also covered a floating ground, which describes the condition where the negative terminal of the high-voltage system is not directly connected to the vehicle's chassis, reducing the risk of electrical shock or damage to the vehicle's electrical system. The one-hand rule is a crucial safety practice for anyone working with or around high-voltage systems. This rule minimizes the risk of completing a circuit through the body by keeping one hand tucked away, reducing the chance of life-threatening shocks. We also discussed an interlock circuit, which is a safety device in electrical systems that prevents hazardous conditions by detecting abnormal conditions and isolating the high-voltage circuit in case of a fault, thereby preventing electric shocks or damage in BEVs. We covered isolation fault detection system. It is a crucial safety feature that monitors high-voltage circuits for breaches or leaks of electricity from the isolated circuit to the vehicle chassis, taking multiple actions when a fault is detected to ensure safety. We also learned about voltage levels, including low, intermediate, and high voltage. Low voltage levels pose minimal risk with DC around 30 volts and AC about 15 volts, marked with RMS for AC circuits, and do not have color for the outer coverings. Intermediate voltage levels are between 30 to 60 volts DC or 15 to 30 volts AC, demanding more caution, and do not have a universal color for the outer coverings. High voltage levels exceed 60 volts DC or 30 volts AC and are marked with orange coverings. High voltage levels pose extreme risks due to their inherent danger. Remember, safety is utmost when working with high voltage systems. Before performing any work on a BEV's high voltage system, always prioritize safe work practices, consult relevant federal, state, and industry regulations and guidelines, and refer to the manufacturer's guide as the make and model of vehicles differ. Thank you.